This is 3.3 part 2, and in this question we're going to begin by doing a question that would be found in Math 9. We're just going to review the concept of it. So the question says, simplify the following expression by combining like terms. So simplify means you're going to condense it down a little bit. Combining like terms means to look at this and put the stuff together that belongs together, that's the same size algebra tile. So what you want to remember first of all is this is 4x squared. And his shape of algebra tile looks like that. Who else in here has the same shape of algebra tile? Well, this guy and this guy. What you also want to remember from Math 9 is that if you're given a term, he owns the sign in front of him. So this is a negative 6x squared, whereas this one, even though you don't see it, is a positive 4x squared. I'm going to rewrite this, and I'm going to rewrite them in the order that puts the same shaped tile together, minus 6x squared. Now this is minus 3x. X tiles look like this. This is a negative 3x, which means that those would be shaded in dark, minus 3x, and plus 5x. And lastly, I'm going to, those are those guys, have plus 4 and plus 3. Your next step is to combine each group. 4x squared minus 6x squared. Two ways to think about this. Imagine having 4 of these ones light and 6 of these ones dark. 4 sets will cancel out, leaving you with 2 darks. So that would be negative 2x squared, or 4 minus 6 is negative 2. Negative 2x squared minus 3x plus 5x is plus 2x, and plus 4 plus 3 is plus 7. The last part of this page, we are going to take the concept of a greatest common factor, or GCF, that we learned earlier just dealing with a bunch of numbers. And we are going to apply that concept to algebraic expressions. We are going to find a GCF of this. And we're going to do it, first of all, using algebra tiles. Later on, I'm going to show you the same process using factor trees. On the side, I've given you, as usual, some steps. So if you find yourself getting lost or confused, these steps can help you find your way. So I'm going to do all of the steps to begin with here, and you're going to find that as you get better at this, you're going to be able to combine some of these steps in one shot. So first of all, it says to just draw the tiles that I need. So I need a couple of X tiles, and I'm going to choose to draw them this way. And I need 6 little guys. The next one says divide the tiles into groups that each contain exactly the same number of tiles. Another way of thinking of this is imagine that this is candy. This is 2 chocolate bars and 6 pieces of gum. And your job is to pass this out to some kids so that those kids will each get the same amount of candy, and you're not allowed to break these into pieces. How many kids would you be able to feed? Well, I only have 2 chocolate bars, so that means I'm only be able to feed 2 kids. I'm going to combine steps 2 and 3, where I'm going to divide my candy into 2 piles, but I'm going to do it in 2 rows, one under the other. So steps 2 and 3 together will look like kid number 1 gets a chocolate bar and 3 pieces of gum, and kid number 2, also my chocolate bars got a lot bigger, but that's okay, gets the same thing. Step number 4 is the most important step in this particular process, where it says form the stack of rows into a tight rectangle. And the way I've drawn it, all you need to do is really squeeze them together. If my X's had been drawn the other way, like if they had been drawn this way, it wouldn't work very well, so I would probably need to turn them this direction. You need to play with that so that it'll actually form a rectangle. So step 4 is going to look like this right here. Step 5 is where you actually begin to find what we call the factors. And the factors are actually how long and how wide this rectangle is. So imagine for a second you standing here and walking all the way to the end of this rectangle. How far would you walk? How long is this? Well, this is X long. and each of these are 1 long. So this is x plus 1, 2, 3. How long is this side here? Well, this is 1, 2. This is 2 long. So step number 5 is just to identify how long each side of the rectangle is. Just so you know, each of our 3 shapes has a unique length and width. This guy is called an x squared, but he is x long by x wide. This guy is called an x, and he's called an x because he is x wide and 1 long. And this guy is called a 1, and he is a 1 by 1, 1 long and 1 wide. Step number 6 says to take your length times width and just write them down. Well, this guy is x plus 3 long, and to keep that contained, I'm going to put that in brackets. How wide is he? Well, he's 2 wide. And this times sign I'm going to write as a dot. But right away I want you to realize that this bracket and this number being after it automatically mean multiplication. So the dot doesn't have to be written. Step 7 just tells me the right order to write my question so that I write it down properly. And all it means is you're going to look at these guys and you're going to choose the one who's the monomial. This is the monomial. It only has one term. And it's going to go first. The guy in the brackets, the binomial, is going to go last. This is the factors of my original question. And this, in fact, equals my original question, but this is factored form. And most importantly, this 2 right here is my GCF.